Hi everyone, welcome to AI Crack channel. This is Akash Khangwar and today we'll be studying matrices and determinants lecture 4. So we'll be talking about determinants and its properties in this lecture. So let us first understand the basic definition of determinants. So determinants are actually square matrix and it's actually a scalar number. So how do we write a determinant? Let's say this is A, B, C, D, E, F, G, H, I, right? So basically this is defined for a square matrix. You cannot write determinant for a horizontal matrix like A or B. We cannot determine a determinant for these kind of matrices. We can determine determinants only for square matrices. So that is the first point. And also it's a number. So it's not something like matrix. It's written in the form of matrix, but it's not a matrix actually. And it's actually a number. So you can find out certain numerical value for this one. Let's say plus 5 or minus 5, right? Like this. Okay. And I think this everyone knows. So let us directly talk about opening a 2 cross 2 determinant. So let's say I have this A11, A12, A21, A22. If I want to take the determinant of this matrix, so what I'll do, I'll do the cross multiplication, multiplying these elements and multiplying these elements and subtracting them. So that would give me A11 dot A22 minus A12 dot A21. So this is how we open a determinant, multiplying this and subtracting the product of A21 and A12. Okay. Now let us talk about minus and we'll understand what are minus with the help of an example of this 3 cross 3 matrix. So basically we'll be needing minus to find out the values of 3 cross 3 determinants, right? We won't be limiting ourselves to just 2 cross 2 determinants. We'll have to calculate the value of determinants which are 3 cross 3 form, right? So for calculating that, we'll have to calculate minus and cofactors. Study cofactors after this. Let's focus on minus first. So let's say I want to find out the minor M11. Then what is M11? Basically a minor corresponding to this A11 element, that is M11. If we want to find out the minor corresponding to this element, then I'll write it as M12. For this, I'll write it as M13. Now how to calculate M11 or any other minor? So if I want to calculate minor corresponding to A11, then I'll select that row and column and hide it, and then we'll use the 2 cross 2 determinant formula, right? That would give me A22 dot A33 minus A32 dot A23. So this is my M11 minor, right? Similarly for M12, I'll select this element and hide the rows and columns in which this particular element is being placed. So this is the column and this is the row in which this element is present, right? So we'll hide this one and we'll use the 2 cross 2 determinant formula for this and this. Okay, so that would give me this multiplied by this minus this multiplied by this, A21 minus A21 dot A33 minus A31 dot A23. So this is my M12. This was my M11, right? So similarly for A13, we'll be crossing this and this, and now we'll be using our 2 cross 2 determinant formula in this particular matrix or determinant, right? So this is how minors are being defined. Now, if you talk about cofactors, cofactors are nothing but just with minus 1 raised per I plus j format of minors. So basically, this is having I plus j as even, that is 1 plus 1, that is even. In this case, we have odd. So over here, it would become negative. Over here, it would become positive. So this is positive, this is negative, this is positive, this is negative, this is positive, this is negative, positive, negative, positive, right? So you can see that this number, this number, this number, and this number, these are negative. The rest of them are actually positive. Okay. So now why are we studying cofactors and minors? So we will be using cofactors and minors on how to open a 3 cross 3 determinant. Okay. So let us look at that. Opening a 3 cross 3 determinant. Before starting with that, what we'll have to create a cofactor matrix. That would be C11, C12, C13, C21, C22, C23, C31, C32, and C33. And this is nothing but, in reality, this is nothing but M11 minus M12, right? Because minus sign over here, negative sign over here because of minus 1 plus 2 over here, right? And this would become M13. This would become minus M21, M22 minus M23, and this is M3, sorry, this is M31, this is minus M32 and M33, right? So these four are with the negative signs. So this and this actually is the same thing. These are the cofactors only. Okay. Now opening a 3 cross 3 determinant. Now we must be remembering that when we open a determinant, let's say this is A, B, C, D, E, F, and G, H, I. If we use our traditional method which we have studied earlier, then what we do, we select A times EI minus FH minus B times we'll be doing DI minus GH plus C times we'll be doing DH minus GE. This is what we actually do without understanding the significance of this particular sign. Now let's try to understand with the help of cofactors. So let us say this is our matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Now we'll be finding the cofactor matrix for the same. That would be C11, C12, C13, C21, C22, C23, C31, C32, C33, right? This is our cofactor matrix. Now, how to use this cofactor matrix to find out the value of determinant? So basically what we'll be doing, we'll be multiplying this with this cofactor, adding this and product of this, adding this and product of this. Basically, A11 dot C11 plus A12 dot C12 plus A13 dot C13. This is what we have been doing. Cofactor is nothing but if I am writing this cofactor, what is this? Basically, this is A22 dot C3 A33 minus A32 dot A23. This is what cofactor one C11 is, right? And similarly, C12 is nothing but hiding this and this, multiplying A21 dot A33 minus A31 dot A23, right? So we have written that our traditional formula in this particular format, A11.C11 plus A12.C12 plus A13.C13. Or we can do this for any row or any column. If I want to open my determinant from this one, from this row, so I'll be doing A21.C21 plus A22.C22 plus A23.C23. I can do this for any row or any column. If I want to do it for the column as well, then I'll be getting A11. Suppose I'm doing for this column, A11.C11 plus A21.C21 plus A31.C31. All these values would be equal to the value of determinant only. We can find out the value of determinant by opening it with the help of row 1, row 2, row 3, column 1, column 2, column 3, and with the help of these cofactor matrices. And the answer would be exactly the same. Now, the important property about this cofactor is we talked about product of A11, C11, A12, C12, A13, C13, and that is giving us the value of determinant. What if I do A11 dot C21? Basically, I'm multiplying this row with this cofactor row, right? Second row of cofactor, not the corresponding row of cofactor, but the second row of cofactor matrix, right? So what I'm doing, C11 dot C21, sorry, A11 dot C21 plus A21 dot C22 plus A13 dot C23. This is not A21, this is A12. Okay. If I'm doing this, basically multiplying one row with the another, not the corresponding, but the another cofactor row matrix, right? Then in that case, this value would be 0. Okay. So if I multiply this row with this row piece by piece, item by item, if I do that and make the sum and do the summation, then also I'll be getting 0. If I multiply this with this, then also I'll be getting 0. If I do multiply this with this, then also I'll be getting 0. We'll get the determinant only when we multiply this with the corresponding row or corresponding column, right? In every other case, we'll get the 0 as the answer. This is a very important property of cofactors, right? So we'll be limiting our lecture 4 for matrices and determinants till here only, because these all are very theoretical and we'll be studying more theory going forward. That's why I'm taking it slow, a little slower as compared to the usual ones. And there are no certain examples for these kind of properties and theory. So we'll be doing questions a little later when we do something substantial. Before that, we'll be continuing with the theory, and that's why I'm taking a little slower in the theoretical part, right? So let's meet tomorrow. Thanks for watching.